Thank you, everybody. I just decided to use this opportunity to look at this question, which was set by National Open University in either second semester in Math 305, called Complex Analysis 2. It's a trade credit load, and this is the number one compulsory question which was set, even though it has B. So I'm using this opportunity to just try my best to see what we can do in this question number one. Now, looking at this question, it looks like a double integral or a line integral, complex integration, whereby the given problem here is from 0 to 3 as a lower limit and 2 to 4 as an upper limit in this function 2y plus s squared dx plus 3x minus y dy along the first parabola. Let's start with the first one. Remember, you are given something. What you are given there is s equals to 2x, which is a parabola. That simply means that you are going to substitute them into this equation. This place is y, but in the question they have already given me that y is t squared plus 3. So you are going to do some substitution. But before you do that, I would like you to understand what this means. Look at this, 0, 3 and 2, 4. Now, this one is x, this is y, this is x, this is y, which is our normal coordinate, which we've learned in our normal secondary school, which we know. Okay? So, after considering that, I will like us to do the little substitution. That is 2y. Instead of y, I'll put t squared plus 3 and then plus s squared. S squared, that is going to be, since x is 2t, then s squared is going to be 2t all squared. Then everything is under the x. Remember, we have 0 to 3, and then we have 2 to 4. Then plus. The next one is 3, and x is 2t. Then minus y. Y is giving us t squared plus 3. And everything is being multiplied by dy. Remember, this dx and this dy can be substituted because they have already been given. They say that x is 2t. This implies that the x dt is given as 2, which implies that the x is going to be 2 dt. So this dx, I'm going to remove it and put 2 dt because the x is this ds and this ds is this. So this is this. Then for y, which is given as t squared plus 3, we are going to do a little substitution also. We're going to, before that, we are going to do derivative. We are going to say dy over dt is given as 2t. This is a constant. This constant will be 0. If I differentiate this constant, I'm going to have 0. So this implies that dy is going to be 2t dt. So I'm going in here to change this x as 2 dt and change this y as 2t dt. So, but before I go there, before I do that, I would like us to deal with this. Let us deal with this, because being able to change this 0 to 3, 0, 3 and 2 to 4, this is the upper limit, this is the lower limit. We should be able to interpret this. How do you interpret this? You have 0, 3, I said it before, 2, 2, 4. Like I said before, this is x, this is y, this is x, this is y. Now, from this, you remember they said that x is 2t. They said that x is 2t. Now, and also they said that y is t squared plus 3. Now, see what happened. X, we have x1 and we have x2. This implies that x can be 0 and s can be 2. So, for this, you ask yourself, if I say that x is 2t, what will I call 0? What will I call t? So that I will still have x as 2. What will I call t? So that I will still have x as 2. And what will I call t? So that I will have x as 0. So we have two x is going to have two values. It's going to have 0 and 2. Now, t will also have two numbers. There are going to be two numbers for t. And before we'll be able to do that, because this is called a parametric equation. This parametric equation means changing everything about x for them to be expressed in t. That is called parametric equation. Now, I think if I say t becomes 0, if t is 0, what will be x? X will be 0. Then, if t is 1, what will be x? X will be 2. Because if I say this t now to be 0, x will be 0. If I say that t is 1, x will be 2. This implies that instead of having 0, 3, I'm going to have 0 and 1, which means that t is going to be 1 and greater than 0.